Predicting the starting materials of a dehydration or a dehydrohalogenation reaction can be more challenging than predicting the starting materials of a substitution reaction because of the question of regiochemistry, or where in the molecule the reaction takes place. Now, it has to take place where the leaving group is, but in the case of the elimination reaction, we're also pulling a hydrogen from adjacent to the leaving group, and so that can often give rise to multiple products. In the reaction where we're asked to find or predict the exclusive product of a reaction, what we mean is the starting material that would give that product and that product only. So here's one such example. Give it a try and see what you can do. And as we're thinking about this problem, we want to recognize that the alkene involves 2 carbons, and we'll put a square and a box in it. Alkenes don't undergo rearrangements in E2 reactions, which is to say, alkyl halides don't undergo rearrangements in E2 elimination reactions. So that means the starting material had to have had that same carbon framework. And we'll draw in hydrogens on nearby atoms so that we can keep track of them. And of course this would have a hydrogen as well, maybe 2. And our question is to recognize that, or our task is to recognize that when we made the alkene from an E2 elimination, we also produced as a byproduct HX, or in this case, since the question asked for the alkyl bromide, we're producing HBr. So that means that the hydrogen was on 1 carbon originally from our double bond, and the bromine was on the other carbon. And you've only got 2 carbons that are involved in the double bond, so you really can have a 50-50 guess of which place it was. So when in doubt, let's draw it out, and let's just say that the first case, we'll put the bromine here and on the circle carbon, and we'll leave the hydrogen on the square carbon. And then for the other example, and we can draw out the entire molecule if we want to, just to make things a little more clear. We'll say there were 2 hydrogens on the circle carbon, and the bromine came from the square carbon. And in an E2 elimination, of course, we're taking out the leaving group, and then we're also taking a hydrogen from an adjacent carbon, and we're using those 2 empty spots to form a double bond. Now, in this molecule, the carbon that's adjacent to the circle carbon on the left has no hydrogens. It's quaternary. So the only possible place to put the double bond is where it's shown in the product. And, well, maybe there's 2 correct answers. So if we think about what would happen if we did the same elimination reaction here, we could still form that same product. Let me write that in a different color. If we take this hydrogen and the bromine, we can still form that same product, but we could also take one of the hydrogens from one of the methyl groups along with the bromine, and if we did that, we would get an additional product where the double bond is not between the circle and the square carbon, but between the square carbon and one of the methyls. So we'll make that the triangle carbon. So we'll get 2 products. Now the more, according to Zaitsev's rule, which is what dictates regiochemistry in these types of reactions, will favor the more highly substituted product as the major product. But we'll still see some of the other products. Maybe it's only 10%, maybe it's 30% of the product mixture. Whereas the first case, since we simply cannot produce the double bond anywhere other than the desired location, that's the one where we're going to get this alkene as the exclusive product. So the better answer in this case then is this alkyl halide.